This video is going to talk about the quadratic formula, and we've already been over it before, so this is a review, but we are going to focus this video on imaginary and irrational roots. So your practice work that you have has 10 problems. You need to complete all 10, but I'm going to record the odd ones to help you if you get stuck. So let's just dive right into number 1. Yesterday you worked on quadratic equations with real rational roots, so you know whole numbers and fractions, and this is going to go the same way, but our answers are just going to look a little bit different. So we're still going to start by making sure our equation is equal to 0, and then we are going to go in and identify A, B, and C. So remember that standard form of a quadratic equation is ax squared plus bx plus c. So that means that the coefficient of x squared is a, the coefficient of x is b, and then the constant, or the number with no variable, is c. So in this case, a equals 1 because there's no coefficient, b equals 4, and c equals -1. So now we're going to plug that all into the quadratic formula, which, reminder, that is x equals -b plus or minus the square root of b squared minus 4ac, all divided by 2a. So we are just going to substitute these numbers into that formula. So we're going to get x is equal to -b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. And you can see that as I went, I put parentheses around every substitution, and I just put these numbers in for their variable. So let's simplify now. I like to simplify in parts. I like to treat this as a section, this is a section, and this is a section. And so we'll kind of simplify each one. So first we have x equals, this just simplifies to -4 plus or minus the square root. This 4 squared is 16 minus 4 times 1 times -1 is going to give us +4. All divided by 2. So then when we simplify even further the stuff inside the radical, we get -4 plus or minus the square root of 20 divided by 2. And then 20 is not a perfect square. In all our examples yesterday, we had perfect squares. So we need to remember how to reduce a radical or simplify a radical. And the way that we do that is by listing, so you can list the perfect squares for reference. That will help you. So when we say perfect squares, we're talking about numbers that when you take the square root of them, you get a whole number. So to find that list, we say 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 36, 49, and continues on. And the way that we simplify this radical, and the radical we're interested in is the square root of 20. So our radical that we want to simplify is square root of 20, and we want to find the biggest number in this list that you can divide into 20 evenly. And the biggest number that goes into 20 evenly is 4. 4 times 5 equals 20. So we are going to split the square root of 20 into the square root of 5 times the square root of 4. I said that backwards, but you get the picture. Because 4 times 5 equals 20. So we're allowed to do that. And then we can simplify the square root of 4. That equals 2. And then the square root of 5 can't be divided by any other perfect squares except 1, but that doesn't help anything. So it's going to stay the same. And then when you write this in the correct form, it's just 2 square root of 5. So then we've simplified this square root of 20. So we're going to just take our 2 radical 5 and substitute it in for that section. So we now have x equals negative 4 plus or minus 2 square root of 5 over 2. And when this part here is not a normal number per se, if it has a radical in it or it has an imaginary number in it, you don't have to split this up into different scenarios. You just have to simplify as far as you can. And something you have to look at whenever you're simplifying these is you need to look at this number, this coefficient, and this number and see if you can reduce them by finding a greatest common factor. And so all 3 of those numbers are divisible by 2. So what we're going to do is see what that gives us. We have, so negative 4 divided by 2 is negative 2, plus or minus 2 divided by 2 is 1. And we leave the square root of 5 alone. We cannot do anything to it because it's under a radical. It's protected by this radical symbol. You can't get to it. And then 2 divided by 2 on the bottom is 1. Now, we know that anything divided by 1 just equals itself. So we're going to be able to get rid of that denominator and it's not going to be a fraction anymore. And we also know that when something has a coefficient of 1 times the square root of 5 is just the square root of 5. So we also don't have to write that 1. So the simplest version of this answer is going to be negative 2 plus or minus the square root of 5. And that is our answer. That's the solution. There's the positive solution, or where negative 2 plus the square root of 5, and then there's the negative 2 minus the square root of 5. Those are our 2 answers. For number 3, you're going to notice that our equation is not equal to 0, so we need to move some things around. I'm going to shift everything to the left just because that's kind of my usual style. It doesn't really matter which side you put it on, but we're going to subtract 7x from both sides. And then we also need to subtract 16 from both sides, so I'm just going to write that over here. So these are both going to go to 0. And this 5x minus 7x will give us negative 2x. So I'm going to bring down the x squared, combine these, minus 2x, and then we have a negative or a minus 16 to put on the end. And that all equals 0. So this means our a value is 1. Our b value is negative 2. And our c value is negative 16. We're going to plug those into the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. So we're going to reduce this, simplify it. We're going to get negative 2, which is a positive 2, plus or minus the square root. Negative 2 squared is negative 2 times negative 2. That gives us positive 4. Minus 4 times 1 times negative 16, which is going to be plus 64. All divided by 2. So then we'll simplify the stuff under the radical to get the square root of 68. And then at this point, we have to make sure that this radical is simplified as far as it can go. So I've put our list of perfect squares over on the side just for reference. And this is only from 1 to 10, like 10 squared is 100. Obviously, these go on forever. You can square any number. You can square 1,000,000. But usually you don't need to go past, I would say 20 is the more common stuff, is 20 or less. Anyway, we want to find the biggest number on our list that divides evenly into 68. So over here to the side, the square root of 68, and we want to break it into two different radicals. So if we look at our list, 64 is the first number that's smaller than 68, but that's not going to go evenly. 49 does not work. 36 does not work. 25, no. 16, no. 9, no. But 4 does work. So we're going to split up the square root of 68 into the square root of 4 times the square root of 17, because 4 times 17 is what equals 68. This reduces to 2, and then we bring down the square root of 17. So this is what we're going to substitute back into our answer before we simplify the rest of the way. So we have x equals 2 plus or minus 2 square root of 17 divided by 2. And again, we have to check all three of these. It can't just be a couple of them. All three numbers have to have a number they're divisible by, a greatest common factor. So these are all divisible by 2. So this is going to equal 2 divided by 2 is 1. So 1 plus or minus 1 square root of 17 divided by 1, because we divided all these purple numbers by 2. Now we know that this one and this one are not necessary to write. So we're going to write our final answer as 1 plus or minus the square root of 17. Number 5, we have to do some moving around again. Again, just kind of out of habit, I like to move things from the right to the left. So you always have to do the opposite of what's happening. So like this is a positive x squared. So we're going to subtract x squared. So let's subtract x squared from both sides. We need to subtract, which is the opposite of addition, 3x from both sides. So like these two are going to give us 0. We're going to subtract 3x from both sides. That's going to give us 0. And then we need to add 28 to both sides. So I'm going to put that over here out of the way. This is going to give us 0. So then we need to combine, and I always go from the biggest exponent to the smallest, because that is typically standard form. So 2x squared minus 1x squared is x squared. So took care of that. 11x minus 3x is positive 8x. Took care of that. And then we have this left over plus 28. And all of that equals 0 because we canceled all this stuff out. So now that we have our equation in standard form, we know that A equals 1, B equals 8, and C equals 28. And we're going to just start substituting. So we have x is equal to negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. And simplify. We get negative 8 plus or minus the square root of 64 minus 112 divided by 2. Then we simplify the stuff under the radical, and we get negative 8 plus or minus the square root of negative 48 divided by 2. Now, when we look at this radical, it has a negative under it. And we've always been taught that you can't take the square root of a negative number. But if you remember, we learned about this magical number I, and it's called an imaginary number. And that imaginary number is equal to the square root of negative 1. So when you have a negative under a radical, before you break it down, what we're going to do, we have the square root of negative 48. So before we look at our list that we use, we are going to break this down into the square root of negative 1 times the square root of positive 48. Because negative 1 times 48 is negative 48. And we know that the square root of -1 equals this imaginary number I. So that's going to be part of our answer. And then we're going to divide the square root of 48 into two other numbers. We're going to treat it just like we've been treating the other problems. So I've put our list back up, or at least part of it. And the biggest number on our list that goes into 48 evenly is 16. And when we divide 48 by 16, we get 3. So we're going to split it into the square root of 16 times the square root of 3. Because 16 times 3 equals 48. Now we're going to reduce so the I stays like it is. And we need to reduce the square root of 16 to be 4. And then bring down our square root of 3. And now each part is as simple as it can be. So we have to combine it in proper form. And so this is all going to be written as 4i square root of 3. So you put the coefficient first, then the imaginary I, and then the radical. And this is what we need to put back in up here for the square root of -48. So let's take all of that and come over here. We now have x equals -8 plus or minus 4i square root of 3 divided by 2. So this time we still have our three numbers. We have a -8, we have a 4, and we have a 2. And we just kind of lump the I in with the radical. We're not going to touch those because they are special. But 8, 4, and 2 are all divisible by 2, so that's what we're going to do. -8 divided by 2 is -4, plus or minus 4 divided by 2 is 2. We keep the rest of it the same. And then 2 divided by 2 is, 1. But we know that we don't have to write the 1 in the denominator. So it's just going to be -4 plus or minus 2i radical 3. So let's do another example with imaginary numbers. I'm going to move everything over. Helps if I'm not writing in boxes. Minus x squared, minus 9, minus 9. And you'll notice I usually line stuff up with its like term. I just think it's easy to organize that way. So we're going to get x squared plus 4x plus 5 equals 0. Because those guys are going to give us zeros. And that tells us that A equals 1, B equals 4, and C equals 5. So let's substitute. X equals -b plus or minus the square root of b squared minus 4 times A times C, all divided by 2 times A. And we will simplify. X equals -4 plus or minus the square root of 16 minus 20, all divided by 2. And then we will reduce again or simplify again. -4 plus or minus the square root of -4, all divided by 2. So then we're going to take the square root of -4 and simplify it. The square root of -4, and remember, anytime we have a negative before we address our list of numbers, we want to split it up into -1 times our number. So this is going to be the square root of -1 times the square root of 4, because we know the square root of -1 is equal to I. But in this case, 4 is also a perfect square, so we also know the square root of 4 is just 2. So we don't even have to look at our list. I times 2 is just going to equal 2i. So this is what we will put in place of the square root of -4. So we now have x equals -4 plus or minus 2i divided by 2. And again, we're going to look at each of the three numbers and see if they can be divided by anything. And they are all divisible by 2. So this is going to give us -2 plus or minus I as our final answer. And finally, number 9, the last example I'm going to do with you. Let's subtract the 7, get it over here, and we're going to have 4x squared plus 15. Now, the problem here is that we don't have a b term. So, we can just recognize that if there's no x term, then b must be 0. Or if it helps you to visualize it better, we can say 4x squared plus 0x plus 15 equals 0. Because we know that if we were to simplify 0x, it would disappear and we would just be left with our 4x squared plus 15. But we need to know what that b value is, so it may help you to look at it this way. So in this case, we have a is equal to 4, b is equal to 0, and c is equal to 15. So let's substitute those in. X is equal to negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. So when we reduce this, negative 0 is just 0, and 0 plus or minus anything is just itself. So we're actually not even going to have anything here in this situation. We're just going to have x equals plus or minus, so either positive or negative, square root of 0 squared is 0, negative 4 times 15 is, I'm sorry, that should be 16. All of these 5s should be 6s. 23 minus 7 is 16, not 15. So 4 times 4 times 16 is going to give us minus 256. That's all going to be divided by 8. And when we do 0 minus 256, we get the square root of negative 256, all divided by 8. So when we have a negative radical, we're going to split it into the square root of negative 1 times the square root of 256. We know the square root of negative 1 is I, and then we're going to multiply that, but the square root of 256 is a perfect square again, so that just equals 16. So 16i is what we're going to put in place of the square root of negative 256. So we now have x equals plus or minus 16i divided by 8. And in this fraction, or in this answer, we only have the 2 numbers to check on. And they're both divisible by 8. So we are going to get x equals plus or minus 2i as our final answer. All right, have a great day.